So now let's remind ourselves of how to name compounds. The fancy word for naming things is nomenclature, or if you're British, nomenclature. What we tried to come up with, what IUPAC tried to come up with, was a simple and yet complete set of rules for naming compounds. So what we have to do first is to decide whether the compound is ionic or covalent. The system is different for those two, so first we have to identify which one it is. You'll remember that for it to be an ionic compound, it has to have ions in it, which you'll usually recognize by having metals and nonmetals in the same compound. The way you name the compound is to name the cation first, and then the anion. To name the cation, you just take the name of the element, although we'll have to take special note of naming the transition metal ions because they can have more than one charge. To name the anion, if it's monatomic, if there's only a single atom in the anion, the name of the anion will get an IDE ending. So let's apply those rules by naming these compounds. And if you were in class with me, I would pause and have you all shout out the answer at the same time. So let's look at MgF2. You pause the video and write down the name. All right, MgF2 is magnesium fluoride. Fluoride. Fluoride and fluorine are amongst the most frequently misspelled words in chemistry. It's FLUO, not FLOU. If it were FLOU, it would be fluoride, and that would be silly. So usually a student asks me, does spelling count? And I always respond in the same annoying way. Only if you want to be taken seriously in life. Now you'll notice in naming ionic compounds, it names the ions, but it doesn't say how many ions of each type are in the formula. Remember, IUPAC wanted to make the simplest name, and so we don't need to say how many ions of each kind. But you need to be able to go the other way as well, to go from the name to writing the formula, and you do that by checking the charges on those ions and putting them together in the right proportions. All right, on to the next one. FeO. Pause the video and write the name. Fe stands for iron, which is a transition metal in the middle of the periodic table. And because transition metals can have different charges in different compounds, we're going to need to distinguish which one it is. We need to figure out its charge by knowing the charges on the anion. From its position in the periodic table, you know that an oxide ion has a charge of -2. So that means to make it neutral overall, the iron must have a charge of +2. So we would call this iron 2 in Roman numerals. That's called the stock system of naming. I hope you don't know an earlier system that's been out of favor for a long, long time. I hope your teacher didn't call it ferrous. We're not going to. The stock system is to name the element and indicate the charge on the transition metal with Roman numerals. So that is iron 2 oxide. All right, for the next one, pause the video and write the name. So again, it's a compound of iron and oxygen, but what iron ion is it this time? Each oxygen has a -2 charge, and there are 3 of them. So the total negative charge is -6. So the total charge from the iron has got to be +6, but because there's 2 irons, each iron must be 3+. So the name for this is iron 3 oxide. Last one on this slide. What's new here is that we have a polyatomic ion. Nonmetals bond together to make one of the ions. Pause the video and see if you can name that. That is called calcium carbonate. Now there are many polyatomic ions, but remember, I don't like you memorizing more than you need to. Here's the deal we're going to make. Here are 6 common polyatomic ions, and I'm sorry, I'm going to ask you to memorize those. I hate that. My first year chemistry instructor had me memorize only 2 things all year, and the first one was this set of 6 polyatomic ions. You need to know how many atoms, its charge, and its name. So CO3 is carbonate, NO3- is nitrate, PO4 is phosphate, SO4 is sulfate, OH- is hydroxide, and NH4+ is ammonium. There is a table beside it from your textbook, and I don't mind if you use that table. You might have to on an assignment when I know you have time and other resources. But the ones that I think you know off the top of your head for quick recall at any time are carbonate, nitrate, phosphate, sulfate, hydroxide, and ammonium. Now with those 6, we can build a repertoire. We can extend that repertoire by adding in the oxo ions with different numbers of oxygens. So oxo anions are anions that have oxygens in them. And you memorized that this is sulfate. Here's a system that's going to extend our repertoire. There is another oxo anion, SO3, 2-. You memorize the sulfate. 1 fewer oxygen than the 8 is going to be an ite. So this is sulfite. Similarly, you memorized that NO3- is nitrate. So you could figure out that NO2-, 1 fewer oxygen than the 8, is nitrite. ClO3- you don't know. I know you don't know. I don't want you to memorize that, but if I told you that that was chlorate, then you could tell me that ClO2- was chlorite. But we can extend this even further. There are more chlorine-based oxo anions. And here's how we name them. We're going to use the Latin hyper and hypo. If you're hyperactive, you're more than active. If you've got more oxygen than 8, you're hyper. Well, we don't say the high, we just say the per. So that is perchlorate, more than chlorate. Now, the prefix hypo. A hypodermic needle goes under your skin. So hypochlorite is fewer oxygens than chlorite. Here's another trick you can use to extend your repertoire. If I take one of the anions that I memorized and added an H+ to it, but still retained the charge, that's key, still got to be an ion, still got to be charged, then I would name this by adding the word hydrogen before the name of the ion. So this is a hydrogen carbonate ion. And this, which is still charged, has 2 hydrogens. This is dihydrogen. Whoops. phosphate. I added 2 H pluses to a phosphate 3 minus. So from the 6 ions you memorized and these 2 systems, you've got quite a repertoire now. You should also be comfortable, as I say, writing formulae from names, and I'll give you a chance to practice this on your assignment. Let me point out a trap that some students had fallen in other years. They're so worried about being wrong that they Google the names for their assignment. You don't want to do that. I want you to be learning a system. So please do yourself a favor, study this system in your notes before you try your assignment, and don't Google things. Google won't be available in a pressure situation. Nudge, nudge, wink, wink. All right, that's the ionic compounds. Now let's name the covalent compounds. And you know, covalent compounds are formed when metals bond with nonmetals. This can be quite a big topic. We're going to limit this to only looking at binary covalent ones, and bi means 2. So we're going to name covalent compounds that have only 2 different elements in them. The way we do this is name the first element, followed by the second element ending in IDE, like for the ionic compounds. But with ionic compounds, we don't need to say how many of each kind of atom, because there are charges to base your decision on. In covalent compounds, there are no charges, so we are going to need prefixes for both elements to say how many of each kind of atom that there is. The prefix is the number of atoms of each type. And I hope you know how to count. You could have 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, and that's as far as we're going to need to go together. There's no point in carrying this on ad nauseum. So let's see. I bet you probably already know this. We're going to look at each one of these formulas, and you're going to write the name when we pause. All right, carbon monoxide. Pause the video, write the name. That is carbon monoxide. You'll notice when the first element had only 1 atom, we didn't say the mono explicitly. We didn't say monocarbon. That's assumed for the first element. Another interesting thing is that I didn't write mono and then oxide. That would be carbon monoxide. I drop the vowel at the end of the prefix if the element name starts with a vowel. All right, carbon dioxide. Oops, I gave that away. You don't have to pause the video. I bet you knew anyway that that was carbon dioxide. So it's a good system, a different name for different compounds. All right, I'm not going to slip again. P2O5. Pause the video, write the name. That is diphosphorus pentoxide. All right. Love the system. Sometimes students say, I don't know that compound. The cool thing is you don't have to know. The system works whether you're familiar with the compound or not. Last example on this slide, SF6. Pause the video, write the name. That is sulfur hexafluoride. And another tidbit about spelling. IUPAC says that chemists are going to spell sulfur with an F. If you're writing the Great Canadian Novel, you can write it with a PH, but that's archaic for a chemist. we write sulfur with an F. Why? Because chemists around the world got together and decided that's how you do it. So that's the system, but there are some common trivial names for compounds that have existed long before IUPAC got going. We're going to call these compounds by their common names, which I suspect you already know. So H2O is water. I've seen some jokes out there, but nobody calls it dihydrogen monoxide. All right, the next one can get a little tied up in your memory. See, memorizing never works very well. Pause the video, write the name of NH3. NH3 is ammonia. Remember the contrast with the ion NH4 plus ammonium. The ion is ammonium, just like a sodium ion is sodium. So the ion is ammonium, the neutral NH3 is ammonia. And the last one on this slide, pause the video, write it down. The trivial name for CH4 is methane. And that is just an introduction to the class of organic compounds or carbon-based compounds. We won't look at that system together until next semester. So for now, I'm afraid you're just memorizing methane. One last category to name, that are the acids, and that is less trivial than you would think. It's hard to recognize an acid in the first place. You know that all acids have H in them, but not everything with an H is an acid. So here's what we're going to do for now to make it very clear. We're going to put the hydrogen up front to say, woohoo, it's an acid. Here's the X minus ion that it's made from. And I'm always going to say aqueous to tell you that it's an acid in solution. Some of these things in their pure states are gases or liquids, but to be an acid, we're going to dissolve them in aqueous solution. For now, anyway, and no tricks. If whatever I tell you, you can trust me. I meant what I said, and I said what I meant. An elephant's faithful 100%. So we've got two classes of acids here. If there's no oxygen in the anion, we're going to name it as a hydro whatever-ic acid. So with the non-oxy anion there, just the chlorine there, you're going to pause the video and write the name of HCl aqueous. That is hydrochloric acid, my favorite acid, because it's cheap. All right, next example. No oxygen in the anion. Pause the video, write the name. That is hydrosulfuric acid. So that's what we do if there's no oxygen in the anion. If I have an oxoanion, I can figure out the name of the anion. And if the anion ended in ATE from your memorized list, I'm so sorry, then the name of the acid that I get by adding hydrogen, and note now it's neutral overall, and it's aqueous, that's going to end in ic acid. So pause the video and name H2SO4. That is sulfuric acid. All right, last one. We've added an oxygen here. We've got an oxoanion that we've added an H plus to. Pause the video, name the compound. I memorized that nitrate is NO3 minus, so NO2 minus is nitrite, And if I have one that ends in "ite," then the acid name is going to end in "us acid." That is nitrous acid. So we finished our section on nomenclature, on naming things. We have a good basic vocabulary to work with together.